Hey guys, welcome back to Coders Arcade. This is Ashank David, and in this video, I will be talking about count sort algorithm. Now, guys, this is one of the most important algorithms that are generally asked in placements. So, if you haven't understood about what is count sort, or if you are new to this algorithm, I would highly recommend you to carefully watch this video till end to understand about how count sort algorithm works. Now, the logic seems very confusing at first, but later on, once you understand the logic, you will understand the whole process of how the count sort algorithm works. Then we will talk about the code a little bit, and then we will understand this whole process carefully. So, guys, before I start with this video, I would like to request you to people like, share, and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also so that you won't miss any future updates. And before starting with this video, guys, I would ask you guys to watch our other videos also. If you're new to this channel, I have created a lot of other algorithm videos also that are already uploaded in our channel in this playlist. So if you haven't watched those videos yet, I would highly recommend you to go ahead and watch those videos as well. And now let us start in our main topic, that is count sort algorithm. So guys, as you can see here, we have an array right here. This is our array, and this is our original array. Now this original array contains some random elements placed in the array, and we need to sort it. And to sort it, we need to apply count sort method. Okay, so what exactly is count sort method? Now this type of sorting technique is a category, it comes under the category of, you know, those kind of sorting techniques which does not use comparison based techniques. So for example, in all our previous uh, algorithms, they were all comparison based techniques, but this is not a comparison based. This is purely based on the frequency of the numbers, repetitions of the numbers, how they are repeated, and how they are, kept into the array like that. So this depends really upon the count of the numbers rather than comparing them with each other. And guys, this type of algorithm works properly when there are single digit numbers most of the time in the array, and less number of digits are there. So in that case, this algorithm is far more better than any other algorithm that you have learned so far. Okay, the condition is that the elements should be single into the array. Okay, other than that, everything is very awesome about this algorithm, and this is one of the most asked placements algorithm. Okay, so here we have the array, and here we have all the random numbers placed. So the very first thing that I'm gonna do is I'm gonna take out the count of all the numbers, and I'm gonna create an array called as count. This second array which you see right here is the count array, and this count array is going to it is going to store the count of all the numbers in their indexes. Okay, so these indexes that you see here represents the number, and the values which will be stored in this array will be their counts. Okay, so for example, how many zeros are there in this array? There are no zeros, so I'll put 0 on the count array like this. Understood? So on zeroth index, I've put 0 because zeroth index represent the value 0, and this 0 inside this represents the count of zeros. Understood? So this is about the count array, guys. Okay. So how many zeros are there? Zero zeros are there. Okay. Now let's see how many ones are there. So if we see there is 1, we have 2. So there are two ones in this. So there are two ones in this. So I'll put 2 in the index 1 in the count array. Okay. Next, how many twos are there? So only 1 2 is there. So I'll give 1 in the second index of this count array. Then how many threes are there? So there are totally 1, 2, and 3 threes are there. So I'll put 3 in the count array, third index. Similarly, how many fours are there? There are 1 and 2 fours are there. Okay. Then how many fives are there? There are 0 fives. And how many six are there? Only 1 6 is there. So guys, I have successfully filled the frequency of all the elements which are present into our original array into our count array, in their particular indexes, as you can see. Now, once this is done, next step is to create a position array. Now, this position array will calculate the position of each element in the final answer. Okay. Now, how it will determine what you will put on 0? I will put on 0. Why? Because first understand this thing. To understand about position array, say suppose where this 3 will be placed. If I ask you in this original array, if I sort this array, where this 3 will be placed? 3 will be placed after 2 is placed, right? According to the sorting. If I sort it right now, the final sorting will come as 1, 1, then 2, and then it will come as 3, right? So finally, 1 is at 0th index, this one is at first index, this 2 is at second index, and this 3 is at third index, right? So typically this 3 should come at third index. That means right here, right? But how do I calculate its position correctly? By counting the uh, occurrences of the previous element right here. So how many times 2 is appeared in this? 2 is appeared one time, and what is the position of 2 will determine on the frequency of 1. How many ones are there? So 1 is present 2 times. That means probably first 1 will come here, then 1 will come here, and then 2 will come right here, and then 3 will come here. This is the position of 3, right? Correct. So to calculate the position of 3, I need to calculate the occurrences of 2. And to calculate the occurrences of 2, I need to calculate the occurrences of 1, right? So what we will fill in this position array is going to be, I hope so you have understood my point, right? If not, then please repeat this video process. Okay. So basically what I'm trying to say is, if I want to find the position of 1, then the position of 1 will determine on how many zeros have occurred. Now there are no zeros in this original array. That means 1 will occur at 0 plus 2. 0 plus, you see, 2. 1 is repeated how many times? 2 times, right? So the last one will be repeated twice, and the final index of that one will be 2. Understood what I'm trying to say? Now, I know this is not matching with the answer, but don't worry, don't see it here. I'll tell you about that, and finally how to fill this answer array later on. But initially, this one will come at second index because 0 plus 2 is 2. Then to find where this 2 will occur, we'll have to be adding this 2 with this 1, that is 2 plus 1, and that will be third index. Okay, this is how it is going to be calculated. Then 2 plus 1, that is 3. So 2 will be occurring at third index in the original array. Okay, now I know it is not matching properly yet, but don't worry, we'll make it match later on. Okay, so don't worry about that. First focus on to the main logic here, guys. And yeah, okay, so I hope so that it is very much clear. Now for 3, we will do 3 plus 3, it will give us 6. Then 6 plus 2, it will give us 8. 8 plus 0, it will give us 8. And then 8 plus 1, it will give us 9. I hope so that this is very, very much clear. To get this number, I have added 0 plus 2. To get this number, I've added 2 plus 1. To get this number, I've added 3 plus 3. To get this number, I've added 6 plus 2. And to get this number, I've added 8 plus 0. And to get this number, I've added 8 plus 1, guys. I hope so that this is absolutely clear of how I got the position array. Now, guys, once you finally get the position of all the respective indexes, now it's time to fill our answer. And to fill our answer, see the process. Always start from the last index in the original array and see what it is. What it is 3, right? This 3 is positioned where in the position array? 3 has number 6. What you need to do is you need to decrement that 6 by 1, which makes it 5. This is your final position of 3, this number in the answer vector and the answer array. You understand my point? So 5 is the index for this 3 and we will put this 3 right here. You understood my point, guys? Now you see, next element is 4. So what is the number written at 4? 8. We'll decrement it by 1. It will become 7 and 7 is the final index of this 4, guys. This 4 will be kept right here. I hope so that this is absolutely clear to all of you. Now, why we are decrementing all of these positions by 1? Because here we have 0 and there is no 0 but the indexes are starting from 0, right? So we need to always reduce one index and that becomes the position of the original number in the answer array. I hope so that this is absolutely clear to everyone and everybody is able to understand what I'm trying to explain, right? Let's see the next number, 6. Now this 6 which you see here, if we talk about the position array, 6 contains 9. We'll subtract it by 1, that becomes 8 and 6 will come right here and the 8th index in the answer vector, in the answer array, right? Next up, we have this. So always we are going from the last, okay? And then this becomes 1, okay? Where this 1 will come? What is stored at 1? 2 is stored at 1 in the position vector, in the position array. So I'll subtract it by 1, it will become 1. 1 is the index of this 1, this original 1. Understood? Then 4. Next comes 4. Now guys, see in this case, 4 is already done before. So we will go towards the 4th index. You see the current position of 4 is 7. Subtract it even one more time, it will give you 6. So this 4 right here will be positioned right here. Understood? And then finally, the next element, 3. This 3 will be kept where? Go for 3. On 3 we have 5 subtracted by 1. This gives you 4. On this 4th index we get this 3. Then go to 2. This is our 2. So what is stored in the 2? 3 is stored in the 2. So we will subtract it by 1. This gives you 2 and 2 gets stored in the 2nd index of this answer array. Then we have 3. So 3 on 3 already have 4, right? Yeah, already we have 4. So subtract it by one more time, it will give you 3. On 3rd index, this 3 will come. And if we talk about this last one, go to the 1st index and you see that if you subtract it by 1, it gives you 0 and this 1 goes right here. And bam, guys, you have got the answer. This is how count sort algorithm works, where we carefully first counted the occurrences of all the numbers. We'll count the frequency of the repetitions of the numbers and then later on we count the position. We finally found the position by counting the occurrences of the current element's previous one element. And then we subtract the indexes by 1 by looking at the original array from the last index and then filling up the answer array. And this is how count sort algorithm works, guys. And this is how this algorithm works. So this is the logic of the count sort algorithm, guys. If you have any doubts, please ask me in the comment section below or just repeat the video once and you will understand this process very nicely, guys. Now let's go towards the code and let's see the code once. So guys, we have this function called as count sort where we are passing the given array and the size. And here we have taken the k, which is the first element in the array. We are starting from that first element and we are trying to find the max number. We already know how to find the largest number. Why we are trying to find the largest number? Because we need to make the count array of that same number, right? So in total, there were how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of these 9 numbers, which one is the bigger? 6 is the greatest in this case, right? So what we will do is we will create the count array of 6 size. I hope so that this is very much clear, and that is the reason why we are trying to find the largest number in the original array. Next, we will we will have this count array, right? Initially set to all zeros. As we know, this is our count array. Initially set to all zeros, okay? And then here we have the for loop to put the count of each and every element into the count. So this is how we are arranging the elements in the count array according to their indexes. We are filling this count array, filling all the variables from the ARR of I, which is this actually. I hope so that this is very much clear, guys. So we have filled up the count. Now we will modify the count and we will add the elements with the count of the previous element. This is the position vector. This is the position array. Understood our point? This is that count array. Understood? And then we will later on will define the final output array where we will iterate over that and then we will subtract the count and we will fill that into the final index, guys. I hope so that this is absolutely clear to all of you, right? And then this is just to printing the output, finally copying the contents to the original array and making sure that the original array is changed back and sorted. Well, this is how it works, guys, and I'll give this code into the description below, guys. So yeah, you can go ahead and see that code once, guys. Well, that's it for this video, guys. This is the code and this is the logic, guys. This logic, I know it was intriguing at first, but once you get the nerve of the logic, you will be able to easily iterate and understand how this works in programming, guys. So this is one of the most important algorithms which you should learn, guys. And that's it for this video, guys. Thank you so much for watching. Share this video to more people so that they can also learn this most important algorithm in placements. And yeah, that's it for this video, guys. Thank you so much for watching. Please don't forget to like, share and subscribe to our channel Coders Arcade. And don't forget to press the bell icon also so that you won't miss any future updates. Well, this is Ashank David signing off. I'll see you guys in the next one. Till then, take care. Bye bye.